the epiglottis will cover the larynx. I mean, no, not the larynx. What do you call this part here? The pharynx. Okay? So that the air, I mean the food will not go towards the trachea. Okay? That's why when you eat, you cannot talk and eat at the same time. Because there's a tendency that the food debris will enter the trachea and it will cause choking. That's why if the food debris are still there, you're going to cough and cough because the pressure of the air will push the food debris out of the trachea. Okay? Sige. Yan. So, this is the trachea, this is the epiglottis. So, it closes and open. It closes and open. So, if you're going to eat, the epiglottis will cover the trachea so that it will lead to the esophagus. Not the larynx, kaya is the trachea or the windpipe. Ayos? O, sige. Okay. What will you do if someone got choked? Okay. Okay, we call it as the Heimlich maneuver. Okay, Heimlich maneuver. Now, these are the steps on how to perform Heimlich maneuver. Sa una, kami means standing. Sa una, uso na dunlan ko, dire pa ginhampak. That's not correct. This one is a fatal part here. It may cause the death of the person. Okay, kapag ito yung karate mo, so it's not. Okay, the best thing to do is to do or perform the Heimlich maneuver. What is that? First, lead the person toward forward slightly, stand behind him or her. And then you do the fist. So look at the fist. Okay, make a fist with one hand. Dodo susulong-sulong sa balat. Okay, and then put your arms around the person and grasp your fist with your hand near the top of the stomach, just below the center of the ribs. In this lower portion, softer portion ini. And then, buka mo na, dos pasakaon mo nga, doon yung sumba mo sa bala, pero, okay, pasaka, para doon magdigwa siya. Could you feel like you're pulling out in it? If you do that. Okay, and then, make a quick and hard movement inward and outward. Okay? Until such time that the person will, the object will come out of the person's mouth. Now, if you are alone, you do this. Okay? Okay? Get a chair, then try to hit the softer part here. Okay? That's Heimlich maneuver, DIY version. Okay? Now, kung bata, dire sa likod, hindi sa liog, dire. Much better if you bring the child to the hospital. Okay? Sige. So, the Heimlich maneuver for choking victims. So, the same. So, you can see, this is the softer part. Okay? And then you do the upward movement. So, function of the larynx in speech production. The biologic function of the larynx, prevent air from escaping the lungs. Okay? Prevent foreign substances from entering the larynx. And then forcefully expel foreign substances which threaten the larynx or trachea. Allow me to stop first the PowerPoint presentation and then I'll show you a video. That's it. Oh. Stop that.
semi-permeable membrane from an area of greater concentration to an area of lesser concentration. Here we have red blood cells in solution. The red blood cell has a semi-permeable membrane. Tonicity is the measure of the osmotic pressure of two solutions separated by a semi-permeable membrane. It is commonly used when describing the response of cells immersed in an external solution. Like osmotic pressure, tonicity is influenced only by solutes, such as sugar, that cannot cross the membrane. There are three classifications of tonicity that one solution can have relative to another. Those three classifications are isotonic, hypertonic, and hypotonic. If a solution is hypotonic, there is a greater concentration of solute within the cell than there is in the surrounding solution. As a result, water molecules enter the cell. As the water molecules continue to enter the cell becomes larger and larger. If water molecules continue to diffuse into the cell, it will cause the cell to swell up to the point that lysis, or rupture, may occur. In this demonstration, dialysis tubing and a sugar solution are used to demonstrate a hypotonic solution. First, a 3 centimeter length of dialysis tubing was cut. The tubing was briefly soaked in water, then rubbed between the fingers to open the tubing. One end of the tubing was twisted, doubled back, and secured with an orthodontic rubber band to prevent leaking. The tubing was then filled with a concentrated sugar solution and sugar granules. The second end of the tubing was also twisted, making sure that no air molecules were in the cell. An orthodontic rubber band was used to secure the second end as well. The completed cell was weighed on a digital balance and then was gently placed in a beaker of tap water. After 30 minutes, the cell was removed from the beaker, gently patted dry, and again weighed on the digital balance. As you can see, there was a significant gain in weight from the water molecules entering the cell. If a solution is hypertonic, there is a greater concentration of solute outside the cell than there is inside the cell. As a result, water leaves the cell and the cell shrinks.
Could you check your schedule? What time are you at? What time? 12:20. 12:20. Okay. Again, I'll show you the mucus axillaris clearance. How does our tract?
The air we breathe contains foreign matter such as dust, bacteria, and pollen. Hair-like cells called cilia, as well as goblet cells, can be found in the lining of the respiratory tract called the respiratory epithelium. Goblet cells secrete viscous mucus that forms a layer to trap foreign material. The wave-like action of the underlying cilia mobilizes the mucus layer, removing the foreign matter and preventing it from entering the lungs.
Okay, so can you see the mechanism of the respiratory tract? The way it makes sure how it cleans the air. Okay, so before the air would enter, there are series of checkpoints. Okay, for dust particles, viruses, etc. and they make sure that it will not reach the lungs. Because the moment it reaches the lungs, definitely there will be a problem. Okay? So is there any question? No. Okay, so I think we're going to end our class and welcome to my vlog.